Okay, so this is the first recording for APC, and I'm going to go through all the topics related to mechanics. And this first recording is going to cover all of this kinematics stuff. We're going to go through motion in one dimension, motion in two dimensions, including projectile motion. That will also include vectors. And I'm basically just going to kind of use your book chapter reviews to kind of hit the major points. When we talk about motion, there are four variables that we use to describe the motion of an object. And they are displacement, which is the distance from where you began to where you ended. And displacement is a vector, which means it is independent of the path that you took. All you care about is where you end and where you began. You do not care which path you took to get from point A to point B. You only care about points A and B. And so the displacement is the final position minus the initial position. Then we have velocity. Velocity is the rate of change of displacement. This is kind of the algebraic form. The calculus-based form, which I'm sure will be here in just a second, is that the velocity, the average velocity, is dx dt, the rate of change of displacement. Actually, the rate of change of position. Speed is how fast something is moving, but speed does not have a direction associated with it. So velocity is going to be speed with direction. So velocity is a vector, meaning it's represented by a ray, and speed is just a scalar quantity. It's just how fast are you going. It only has magnitude and no direction. So it is distance over time. And again, we have defined these as average variables. If you're talking about instantaneous velocity, that's when you're really going to take this the derivative of position, where the instantaneous velocity is the rate of change of position at any instant. Acceleration is your third variable, and that is the rate of change of velocity. So it's delta V over delta T. Or if you want the instantaneous acceleration, the acceleration at any moment in time, it is dv dt, the rate of change of velocity, or the derivative of velocity. And the fourth variable that we use, in addition to displacement, velocity, and acceleration, the fourth variable will be time, which keeps showing up here as part of kind of some of these equations. So here are some major things to remember. Acceleration is any change of velocity. And so if you are going to change velocity, there are three ways to do that. You can speed up, slow down, or change direction. When you would speed up if the velocity and the acceleration vectors are in the same direction. They could both be positive or both be negative, but if they are in the same direction, the object will be speeding up. What's tricky to remember there is that you can have a negative acceleration and be speeding up. And the best example of that is if you drop a ball, its initial velocity is 0, but then it starts moving downward with a negative velocity toward the earth, and its acceleration is also a negative acceleration towards the earth. And so that ball tends to speed up as it goes toward the earth. Even though its velocity is negative and its acceleration is negative, it is still speeding up. To slow down an object, the velocity and acceleration should be in opposite directions. Think of this as you're driving forward and you apply the brakes. So your velocity is positive and your acceleration is negative, and the result is a slowing down of that object. The third form of acceleration, which is not in this part very much, but I will talk about it when we get to circular motion. I think the seniors are doing something. Give me just 1 second. I will restart this.